In this episode of creating a Unity ML API multiplayer game series, we'll be taking our game from this to this. At first glance, it may be a little bit hard to see, but our whole goal in this episode is to add player position tracking and player rotation tracking into our Unity ML API game. One thing I want to note about today's episode, we'll be getting into the nitty-gritty about network variables and the server RPC, which at times can get a little bit tricky, so tune in, focus in, and I promise you, you will learn a ton. So enough of me talking, let's get into the code. So let's jump right in. So if you recall from the last episode in our series, we actually ended in our Unity project with somewhat of a broken build of our game. If you don't remember, I'll go ahead and re-show you kind of where we were at last time. So what I'll do is I'll go ahead and open up our old build from our last episode so we can kind of see where we were when we left off. So last time we had built our project, we had our game playing, and we had 2 players in the game. But the issue we ran into is that when we actually played our game with our host and our client, we didn't actually see one-for-one movement in the game. So let's check out what I mean. So I'm going to go ahead and click host here within my Unity editor. And I'm going to go ahead and move my player character up a little bit. Then within our built game, I'm going to go ahead and click client. And as you'll see, when I move my client player around, you don't see any movement reflected in the player's game. So let's go ahead and close the game and stop playing. The issue we're actually running into at the end of episode 4 was actually that we weren't sending information from player to player about their particular position, rotation, or anything about them. And in this episode, we're going to go ahead and take our time, look at what we can do to fix that issue and to get our game working the way that we really desire. So before we jump into the code for today, I just want to mention that today might be a little bit tricky for those who've never worked in networking before. I'm going to try my best to break down everything that we're doing and make sure that I explain how things work, why they're doing what they're doing, and how they have an impact on the game that we're creating. So let's go ahead and jump on in. So what we're going to do is go ahead and jump on over to our editor and look at the code that we had in one of our scripts. That was the movement script. So if you have not already, go ahead and download the Unity package that I have uploaded to my GitHub repo. You can find that link down in the description, and to make sure that we're all starting off at the same exact place. So go ahead and check out the description and download that Unity package so you can be at the same place I am as we continue. So if you go within our asset folder here on the left, I'm going to open up scripts. I'm going to go to this file called movement. Let's go ahead and open up movement. So you'll see here that we have our movement script. If you recall from our last episode, the movement script just managed the movement of our card player, and it ensured that our movement was only reflected on our local player and no other player within our networked game. So today, in order to fix the issues that we've seen amongst the 2 players not being able to see their different positions in each other's games, we need to add some additional code within this movement script. In order to fix the issues that we encountered in the last episode, we need to implement 2 important concepts that we've mentioned before in earlier episodes. The 2 concepts that we're going to need for today are going to be the network variable and the server RPC. So the first concept we're going to start with is the network variable. As mentioned in earlier videos in the series, the network variable allows us to track data across our network seamlessly. In our case, in order to track the position of any particular card player in any particular person's game, we need to use a network variable that manages the position and rotation of our card player. What we're going to go ahead and do is add 2 new network variables to the script that are going to help us immensely in the future. So let's go ahead below our rotation speed variable and add a line that goes public network variable. With inside of these angled brackets, we're going to type vector 3, and we're going to title this variable position. As you can probably guess from what we're doing, this is going to reflect the transform position of any particular player when we're moving them around across the network. In order to initialize this variable, we're going to go ahead and go equals new network variable. We already got the hint that we need, and open and close parentheses and a semicolon. Once again, this is going to be our network variable that we're going to be using to track our position of any particular card player across the network. The next network variable we're going to add is going to be called rotation, and as you can guess, it's going to track our players' rotation across the network. So let's go ahead and add it to our script. We're going to go ahead and type public network variable, which we already got a hint. Inside our angled brackets, we're going to type quaternion, and then we're going to type here rotation. Once again, we're going to initialize our new variable. We're going to type in here new network variable, take our hint quaternion, open and close parentheses, and semicolon. As I mentioned earlier, these two variables are going to be key in order for us to track our position and rotation of our card player objects across our network during our game. But before we continue any further, I need to explain two really important things that we'll need to know about network variables. So here are the two things that you really need to know about network variables before we go any further. First, just like any other variable, network variables need to have their value assigned to them. Sometimes ML API network-based object can seem somewhat like magic, but in this case, network variables are pretty straightforward. You just need to assign a value to them, just like any other variable. The second thing to know about network variables is that they're actually owned by the server and cannot be directly modified by a client. The second point is really the most important thing that you need to know and can be a little bit tricky when you first get started using network variables in real time. So what does it mean that a network variable is owned by the server and cannot be directly updated by a client? What this means is that a network variable can only be updated, modified, or changed by a server or hosting application. In our case, that means that our rotation and position network variables cannot be changed by our clients. That means that any player who is not acting as a host or server cannot directly change the position values or rotation values for our network variables. As I mentioned in one of my previous videos, ML API is a server authoritative networking system, meaning that the server is the only entity that has the ability to change any state on the server itself. There are many reasons for using this type of model for a networking system, but the main reasons is really just for helping for data consistency, and also it's a good way to thwart hackers and cheaters from affecting state on your server. So what this really means for us is that we have to find a way to communicate our players' position and rotation to our server, even though we don't have direct control or access to our network variables in our game as a client. And that's where the functionality of server RPCs come in. As I mentioned in a previous video, quoting Unity directly, a server RPC can be invoked by the client to be executed on a server. What that really means is that even though we don't have direct control over a network variable as a client, if we're not acting as a server or the host, we can use a server RPC as a method to communicate our intentions to the server and the server to act on our behalf in a more authoritative way. Server RPCs allow for our server to update our network variables on our client's behalf. As we'll see in a moment, the server RPC allows us to overcome the limitations that come from using a server authoritative networking model. So before we jump back into the code, you may be wondering, how does a server RPC really differ that much from just using a client directly to change our network variable values? A good way to think about it is that without calling a server RPC method directly in our code, it's very difficult for a client to change state on our server. Think about a server RPC function as a certified way for a client to interact with the server directly. This would mean that even if somebody were to manage to modify our application after it was published, it would be very difficult for their changes or anything that they do on their client side to affect us on the server side. This is just a very simple low-level way of stopping hackers, cheaters, or bad actors from affecting your game in a way that you wouldn't approve of. To be very honest, this is probably the most simplistic way of explaining this type of concept, but just know that at the end of the day, we're giving our server more control over the actions that happen on it and kind of limiting the ability for clients or anybody outside of the server to affect its state. So with all that being said, let's jump back into the code and get back into creating our server RPC functions. Now that we know a little bit more about network variables and how server RPCs work, let's go ahead and implement the new code that we'll need to get things working correctly. So what we're going to go ahead and do is add two new functions that are going to act as our server RPC methods. So the first method is going to be called update player position. So let's go ahead and start adding that code. So we're going to type here void update player position open parentheses, close parentheses, and 2 squiggly brackets. Essentially what this update player position function will do is take in our transform.position for our local player and allow it to be applied to our network variable called position. So the first thing we need to do is we're going to need to add in here 3 input parameters that are going to go into our update player position. So the first thing we're going to do here is we're going to type float. We're going to say x pos, comma, float, y pos, comma, float, z pos. As you can guess, each of these just represent the x position, y position, and z position of our local player transform. All we're going to do inside this method is take our position network variable and set it equal to a new vector using our x, y, and z position of our local transform dot position. So what we're going to type here is position dot value is equal to new vector 3 x pos, comma, y pos, comma, z pos, and then a semicolon. So in order to assign a value to a network variable, you have to actually use the dot value property. So that's why we're doing position dot value instead of position equals. Now that we've created our update player position function, let's go ahead and implement it in our code to see how we should use it. So inside of our update function, inside of our isLocalPlayerPosition, all we're going to add is our function. We're going to go ahead and type update player position, and we're going to go ahead and put in here the different vectors of our local transform dot position. Now that we've added our update player position function in the correct place, you might note that there's something wrong with what we've just done. As I mentioned a little bit earlier, in order for us to actually update our position value, particularly a network variable, we need to use a server RPC. But as you can see, we haven't implemented a server RPC and we haven't done anything like that. So if we try to run this build, we'll actually run into an error. In order to demonstrate what I mean by that, let's go ahead and run and build our project and see what happens. In order to save time, I'll go ahead and build and we'll skip right to the running process. All right, so our game is already finished building and is now running. So let's go ahead and start running our Unity editor version of the game as well. So in order to illustrate the problem that actually happens when you don't use a server RPC, I'm going to go ahead in our built version of the application run as host. I'm going to go ahead and move our player back a little bit. And then I'm going to go ahead inside of our Unity editor run as client. As you'll see, we're starting to get errors within our console. You'll continue to see these errors that say client can't write to networks variables. As I noted before, we cannot as a client write to a network variable outright, so we're going to have to use a server RPC to do it correctly. So let's go ahead and close our applications and let's go ahead and fix our code. All right, so let's get back into the code. So as I mentioned before, we need to use a server RPC in order to make this work. So I'm going to introduce you to a directive called server RPC. So above our void update player position function, we're going to type in here something very simple. We're going to type in open bracket, close bracket, server RPC. So what this actually does is tell Unity and our code that the function below this bracketed directive is a server RPC method. So now when this function is actually called within our local code, it's actually going to be a method that will always be executed on our server and not on our client. One really important thing to note is that anytime you denote a particular method as a server RPC, you also need to change the function name to reflect that. So in our update player position function, I need to actually add at the end server RPC. If I don't do that, if I try to run this code, I'll get an error saying my function is not designated correctly and I'll need to come back and fix this. So let's go ahead and update it here as well. And now our function is good and ready to go. So what we're going to go ahead and do is rebuild and test our application again, and we'll see that our errors have now gone away. So I'm going to go ahead and save, and I'm going to go build and run, and we'll jump back in here in a second. All right, our game is up and running again, now with our server RPC correctly implemented. So let's go ahead and run our game within our Unity editor. Now with our games up and running, we're going to go ahead and run the same exact test as we did before. So what we're going to do is go ahead and make our published player our host. I'm going to move our player a little bit, and then we're going to jump in as a client in our Unity editor. Now, as you see this time, we no longer see those errors that we saw previously within our Unity editor. But as you can probably see, even though we fixed the issue that comes from not using our server RPC correctly, we are still not getting that one-to-one movement in our game. So we're going to need to go ahead and fix that issue. So let's go back to our editor and make those fixes to make everything start working the way that we need. So the issue that we just ran into is actually not that difficult to solve, but it'll probably take a little bit of an explanation to really make sense of why we're doing what we're doing. So let's go ahead and implement the code, and I'll explain it after we finish it. So what we're gonna do is go into our update function and add an else condition to our if local player condition statement. So let's go ahead and type else, open this close squiggly bracket, and let's start writing our code within this else function. So all we're gonna do in this else function is set our local transform position equal to our position dot value. So let's go ahead and type in here transform dot position is equal to position dot value. So what exactly is this doing? So the reason this particular line of code is so important fixing the issue that we just encountered is that it actually allows us to see all positional changes made by all other players. So what do I mean by that? Essentially, when we're using this update player position server RPC function, we're updating the network variable that is being managed on our server for position. The issue arises that even though we're updating our position network variable on our server, we're not letting all the other players know that this position value has been updated in their local game. So what this particular line of code does is ensures that every player object that is not the local player has the most accurate network variable position at any given time. What that means is that you're always seeing the most accurate position for all other players in your game as the game progresses. This particular concept can be a little bit tricky because you need to remember that though we've updated the positional value on our server, that does not automatically update player positions for players who are not the local player in any particular gaming session. So that statement might have been a little bit confusing, but the best way to understand it is to see it in action. So let's go ahead and save our file and run a new build. So our new build is running. So let's go ahead and start our build inside of our Unity editor as well. All right, this time we're gonna let our Unity editor be host. Let's go ahead and move our Unity editor back a little bit. We're gonna go ahead and start our built game as client, and let's move them around. And as you can see, our player position is now being reflected within the game. One thing you might note is that our player rotation is not being reflected, and that's okay. We haven't updated our code to reflect our player rotation, but we'll add that here in a moment. So let's go ahead and close our build and get back into our code. Now back at our code, with everything starting to work, let's go ahead and add in the last bit of code to make sure that our rotation is correctly reflected within our multiplayer game. So all we're gonna do is basically the same steps that we did a little bit earlier to get our position working correctly. We're gonna add our server RPC function and then add it into our isLocalPlayer conditioned statement. So let's go ahead and go down here at the bottom of our code. We're gonna go ahead and start with our server RPC bracket. So I'm gonna type server RPC. From there, I'm gonna go ahead and start writing our new function, void update player rotation server RPC. Gonna go open parentheses, and then we're gonna do squiggly bracket, squiggly close bracket. Now within this update player rotation server RPC function, we're gonna go ahead and pass in our local quaternion for our rotation, and then we're gonna set our rotation.value to our local transforms rotation quaternion. So let's go ahead and add in our parameter. So we're gonna type in here quaternion, and then we're gonna type in here rotation. So in our function here, we're gonna go ahead and type rotation.value is equal to rotation. So just like our update player position server RPC function, our update player rotation server RPC function just takes our rotation.value network variable and sets it equal to our local rotation. From there, all we're gonna do is add 2 more lines of code. Under our update player position server RPC inside of our isLocalPlayer condition, we're gonna type in here update player position rotation. And all we're going to type in here is transform.rotation and end with a semicolon. Now within our else statement, we're going to do a similar thing as our transform. We're going to go ahead and type in here transform.rotation is equal to rotation.value semicolon. Now let's go ahead and save, and let's look at our build and see if our game is working correctly. All right, now with our build game running, let's go ahead and run our editor version of the game. We'll go ahead and set it as host. We'll back it up a little bit, open up our publish game, click client, and let's watch the good times roll. And just like that, we have now implemented our update player RPC position and our update player rotation RPC method. And just like that, we have our multiplayer game starting to really feel alive. Today was just the first step of really diving into the concepts of network variables and server RPCs, and we'll get to see more and more how important this is into creating our multiplayer game. And just know it's okay if you didn't fully grasp today what we covered in regards to network variables and server RPCs. We're going to be covering a lot more throughout the series, and I encourage you to experiment with the code, trying different things out. Just try to see what you can learn throughout the way to learn more and more about these concepts. With all that being said, in our next episode, we're going to focus on trying to synchronize actions across our network in our multiplayer game. In our case, we'll be synchronizing actions of shooting rockets from our battle cars or our car players, and we'll start to get that feel of our game coming alive and really feeling more and more like a true multiplayer game. As always, thank you so much for watching today's video, and if you enjoyed today's video and like content like this, please don't forget to like today's video and subscribe to the channel. More to come, more to do, and so much more I'd like to show you all. Please don't hesitate to give feedback down below in the comments, good, bad, or indifferent. I love to hear what you're all thinking and how I can improve throughout the series. And please don't forget to reach out to me on Twitter at BradstonDev. My Twitter inbox is always open. Please feel free to send me a DM, and I hope that I can help in any way throughout this process. Thank you again for checking out today's episode, and until next time, peace.